Okay, for this transformation, we're going to have a set of coordinate axes, and the biggest number we have in any of these coordinates is a -3, so we're going to want to have at least 3 units on each axis. So, picture might look something like this. Now, 1 unit here is just this big. 1 unit on this picture was this big, quite a bit bigger than this. So this picture is not going to look as big as it should compared to this one. It's actually going to be about 50% bigger in each direction, which will make it look a lot bigger. Okay. Now, same vector here, our 1, 0 vector maps to 2, 0. So there it is. This is the image of the 1, 0 vector. The 0, -3 vector, the 0, 1 vector maps to 0, -3. So that this 0, 1 vector, the one that goes up here, actually ends up going down over here. The image of this vector is this vector. While this vector was in the same direction as this one, this vector here is in the direction opposite this one. Okay? Now let's look at the other two. The 0.87.5 vector, that would be the orange vector here, so let's draw this in orange, goes to 1.74, -1.5. Now 1.74 is out about here, -1.5 is about here. So the orange vector is going to look something like this. And the green vector goes to 1, -2.61. It means it goes 1 unit here and 2.61 units here. That's going to put it down here somewhere. I can draw a curve that follows the pattern of these vectors. Now, I kind of had to cut my labeling short here, so it's not completely clear that this is longer than this, but it is. But it's not quite to scale. So what you're going to have is this distance here is less than this distance. And instead of getting the arc of a circle, as we would get here, we're getting an arc of an ellipse. Now, by reversing the coordinates here, taking the negative of every coordinate, we get the image of the negative of every one of these vectors. So these vectors are here, 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 and here. We're going to get the image of this, 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 and this. And those images will be equal and opposite the images we have here, so that our 0, 2 will become a 0, -2. Our 1.74, -1.5, I'm sorry, it's 2, 0 will become -2, 0. I said that backwards. 1.74, -1.5 will become +1.5. Don't even think about what I just did. What I just did with my words. 1.74, -1.5 will become -1.74, 1.5. -1.74 is about here. 1.5 is about here. And of course, this vector is going to be equal and opposite to this one. My scale isn't great here. I'm also looking at this thing at a bad angle. And you might want to get used to that because this happens quite often. Draw your own pictures if you want them to look really good. Okay, 2.61 is about here. -1 is about here. So that 1, -2.61 on the reverse vector here will become -1, +2.61. So we get -1, +2.61. And then our blue vector, 0, 1, If we go to 0, -1, that's going to give us 0, 3, reversing these coordinates. So we have this part of the picture. Made that orange arrow a little bit too long. You get the idea that, again, we're moving along the line of an ellipse. Now, you can think about this. I'm just going to assert this. If we change one of the coordinates here to make it a negative, if we make the negative of the first coordinate, because of the way the matrix is, that's going to give us the negative of the first coordinate over here without changing the second coordinate. So that 2, 0 would again map to -2, 0. -0.87.5 would map to -1.74, -1.5, and that would be about here. -0.5, 0.87 would map to -1, -2.61, and that would be about here. And then 0, -1 would again map to I'm sorry, change the sign of 0, that doesn't change anything. We're going to get 0, -3. Okay. Then, without further comment, it's not hard to see that we're going to get these vectors, which are equal and opposite to these vectors if we change the second coordinate and don't change the first. Again, you might want to think through that a little bit and see why it should be obvious that that would be the case. Well, if we complete the picture, we get an ellipse. And the other thing is, if we follow these vectors around here, and you can think this through a little bit, but just understand that this is what happens. That reverse, that we follow, well, the vectors that we get down here go in the same order for a while, but they go in the reverse order. Okay, but now the order of the colors changes between here and here. Then here the order of the colors is again orange, green, blue, the same as it would be here. But again here the colors reverse and it goes green, orange, purple. I don't want to say too much about why that happens, but what's really going on here is that in the first and third quadrant, the order of the, let's say, well, the order of the green and orange vectors is different than the order you would have if you're going around this whole picture counterclockwise. So that makes it a little bit interesting. And we're not going to talk about why that is. You can think about, for this particular matrix, why the numbers do that, and that would be a good thing to think about. But there are very sophisticated matrix methods, and we're going to develop some of the easier ones in the course that could explain why that is the case. Okay, the bottom line is that this transformation takes this circular pattern onto this elliptical pattern. It makes it bigger because everything is doubled in this direction and tripled in this direction. So you might think that you would have 6 times the area here that you do here. Doubling everything this way and tripling everything this way actually does give us 6 times the area. And there are a lot of other interesting things that we can understand about this. Okay, well, this is just a brief picture of a couple of kinds of transformations. This transformation is a rotation. This transformation stretches things this way and stretches things this way and also inverts some things. And understanding why transformations do that and how they do it, that's something we get to much later in the course. but it's kind of an interesting phenomenon. It's an interesting picture, and it's kind of a pretty picture.